Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. This is going to be a quick revision video for the quiz coming up on Tuesday, which is tomorrow. I've been asked to do it, and anything for my students as long as it's going to help you. So let's just get on with it. So the quiz is going to cover work, energy, and power. And I'm going to start by answering these questions. If a force of 50 newtons is applied at an angle of 90 degrees to a direction of motion, how much work is done? Okay, so as we've discussed in the previous video, the explanation video, basically, if the force and the direction are perpendicular to each other or at 90 degrees, then no work is done. And the reason for that is because work is equivalent to force times displacement, but that force, if it's on an angle, we have to find the force that's acting in the same direction as the displacement or the same axis as displacement. So we have to multiply by cosine of theta. So cosine of 90 is equal to 0. So the whole thing becomes 0. So basically what you need to remember here is if force and direction and displacement are perpendicular to each other, then the work is 0. And it doesn't matter which is where. So that could be displacement and this could be force. The work is going to be 0 either way. Okay? Next question asks, a force of 200 newtons is used to push an object 4 meters. How much work is done? Well, that's easy. Work is equal to force times displacement, which is 200 times 4 or 800 joules. Which of the following factors affect kinetic energy of an object? So kinetic energy is equivalent to half times mass times velocity squared. So we've got mass and velocity. So mass and velocity, most certainly. The shape, the volume, the density, the size, and the height don't matter for kinetic energy. The height matters for gravitational potential energy, but it does not matter for kinetic energy. Right, so question 4. A 3 kilogram object is moving with a velocity of 4 meters per second. What is the kinetic energy of the object? It's going to be half mv squared. So it's going to be half times 3 kilograms multiplied by 16, which is 4 squared. And that's going to be 1.5 times 16 or 24 joules. Okay, so that's going to be B. If the velocity of an object doubles, what's going to happen to the kinetic energy? So the kinetic energy is going to quadruple, but I'm going to show you the easiest way of doing this. The easiest way of doing this is by putting in some numbers. So I'm going to use a different color for this. So if we put in some numbers, let's say, for example, half times, just make up a number, 2 kilograms multiplied by 2 meters per second squared, yeah? So that's the numbers that I've chosen. They don't matter, but I'm just choosing those numbers. Now the answer is going to be 1 times 4, which is 4 joules. Now what's going to happen is I'm going to double the velocity. So you can see what's going to happen. So if I double the velocity, I change it from 2 to 4, suddenly you can see that instead of 4 joules, I'm going to get 1 times 16. So it's going to be 16 joules. So obviously it's 4 times. So quadruples. It's quadruples, okay? And that's the easiest way of doing these questions. Like if it tells you what's going to happen, just put in some numbers, see what happens, okay? Usually, if it's squared, obviously it's going to quadruple, yeah. Which of the following does not affect gravitational potential energy? So gravitational potential energy is equal to mass multiplied by gravitational acceleration multiplied by height. So those three will affect it. The mass will affect it, the height will affect it, the gravitational acceleration will affect it, the velocity will not. It's not part of this equation. Right. A 2 kilogram object is lifted 5 meters above the ground. That's 2 kilos, and it's lifted 5 meters above the ground. What's the gravitational potential energy? Well, that is going to be GPE is equal to mgh. So that's going to be 2 multiplied by 10 or 9.81. I should be more accurate, 9.81 multiplied by the height, which is going to be 5, which is approximately 100. So it's 98 joules. C, 98 joules. Oh, why is it so hard? Okay, a motor produces 5,000 joules of work in 10 seconds. What is the power output? The power is going to equal work over time or change of energy over time. That's the formula for power, okay? So power is equal to work over time and or change in energy over time. So that's going to be 5,000 divided by 10, which is approximately 500 watts. Now this W is different to this W. This is work. And this has a unit, which is joules. This W here is a unit itself, and it stands for watts, okay? So please don't confuse the two. They have nothing to do with each other. Well, they kind of do, but they're not related. Okay, so that's watts and that's work, but they both have the same symbol, which is W. Okay, so the answer was 500. Let's keep going because I really want to make this as short as possible. Work is done when what? So the work is force times displacement, right? So work is done when force is applied to an object and it moves in the direction of the force, okay? That's important as well. So obviously, if I apply force this way and the displacement is also this way, then positive work is done. Otherwise, if they're opposite to each other, then negative work is done. And if they are perpendicular to each other, zero work is done. Okay, the energy transferred is equal to work done. Power is the rate at which work is done. So once again, we are repeating words here. Or energy transferred over a period of time. Because power is equal to work over time or change in energy over time. Okay, next. A person does 800 joules of work using a force of 50 newtons. How far did the object move? Work is equal to force. Well, actually, I'm going to do the triangle this time so you understand it better. So if you have an equal sign, the thing that is equal goes on top. Work is equal to force times displacement. So that's going to equal, we've got 800 joules, which is work, and we've got force, which is 50. So displacement, or how far it's gone, is going to be 800 divided by 50, which is going to be 40 meters. Okay. Next, I have, oops. Oh, sorry, not 40, 16. Oops. What am I thinking? 16 meters. A 40 Newton push force is applied at 30 degrees to the horizontal to move a 30 kilogram box, 3.5 meters. Calculate the work. So I've got 40 newtons and it's at a horizontal. I want this force here. I don't want that one. And the push is here. So the displacement is equal to 3.5 meters. Okay. So what do I need? The mass doesn't matter. That's just there. Sometimes you have extra information. So work is equal to force times displacement, right? But I don't want this force. I want this force. So how do I find this force? Well, in order to find this force, I have to go cosine 30, because that's 30. Cosine 30 multiplied by 40, because it's going to be cosine of angle equals adjacent over hypotenuse. So it's cosine of 30 degrees multiplied by 40, and that's going to give me cosine of 30 multiplied by 40, and that's going to be 34.6, and then multiply all of that by 3.5, so that's going to give me, divided by 3.5, it's going to give me 34.6 multiplied by 3.5, which equals to 121 joules. So that's one way of doing it. The other way of doing it is just straight away you go work is equal to force times displacement times cosine theta, but then you would use the force they gave you in the question, and some of you might find that easier. So you just go force, which is 40 multiplied by 3.5 multiplied by cosine of 30, and it's exactly the same. Okay, it's exactly the same. It's just it's kind of less mental gymnastics using the formula. Okay, so all of that belongs to this question here. Question 3, sorry. A 2 kilogram object is moving at a speed of 10 meters per second. Calculate the kinetic energy. So the kinetic energy is going to equal half mv squared. So energy kinetic, I write it in different ways. I like to write it energy kinetic, but sometimes I write it like this. So I just want you to get used to both, because that's how you'll see it in physics books. Okay, so energy kinetic equals half mv squared, which is equal to half of 2, which is 1, multiplied by 100. Oops. Half of 2 times 10 squared, which is equal to 1 multiplied by 100, or 100 joules. Question 4. An object has 400 joules of kinetic energy and is moving at 8 meters per second. What is the mass? Okay, so another way you could do this is by separating it. So you can put EK on top, and then half m over here, and then v squared over here. And so that way I can find the mass. So if I rearrange this formula, I know that half of m is equal to EK over v squared. What are you doing? Oh, I know what's happening here. I didn't put the fan on, and so it's overheating. Just a second, sorry. Bear with me. Just a second. Not you, not you, not you, not you. You. Yep. You are the one. Okay. It should be better in about 5 minutes. Sorry, when my laptop overheats, it starts doing funny things. Right, so half of m is equal to the kinetic energy over the velocity squared. So it's going to be 400 divided by 8 squared. And that's going to be 400 divided by 64. That's going to be 6.25. Now remember, what we just found was half of m. So I want m, and that's going to be, so m is equal to 6.25 times 2, which is equal to 12.5 kg. Okay. A 4 kilogram object has 64 joules of kinetic energy. What is the velocity? So once again, I'm going to use the same formula. V squared is equal to EK over half of m. So it's going to be 64 over half of m. What's half of 4? 2 kg. And that's going to be 32. But remember, what we just found was v squared, not v. So I still have to find the square root of this. So v equals square root of 32, which is approximately 26. Square root of 32, which is 25.7, or 5.7, sorry. 5.7 meters per second. An object has 294 joules of gravitational potential energy and is lifted 3 meters. What is the mass? So once again, we've got mgh. So GPE equals mgh. So I've got 294 is equivalent to 3 times 9.81 times the height. So the height, therefore, the height is going to be 294 all over 3 times 9.81, which is equal to 294 divided by 3 times 9.81, and that's going to be 10 meters. Okay, that's how you do that one. Let's move on. A 12 kilogram object has 588 joules of gravitational potential energy. What is the height, or what height is it lifted to? So once again, mgh. So GPE equals mgh. So we've got 588 equals 12 multiplied by 9.81 multiplied by h. So we can do that. 588 divided by, so about 5 meters. Okay. You can round, or you can use decimal places. It's better to round in this instance. A 50 kilogram person climbs 12 meters in 6 seconds. What is their power? So in order to find power, we have to find work, and we divide it by time, right? So work is equivalent to change of energy. So there's 2 ways of doing this. You can find the work, which is force times displacement, and in this case, the force is going to be the weight. So it's going to be 50 times 9.81 multiplied by 12 meters, and that's going to give you the work. So 50 times 9.81 times 12, and that's going to give you 5886 joules. You divide that by 6 seconds, and you get approximately 990 watts or whatever. Now, the other way of doing it is, remember, work is also about change of energy. So change of energy means mgh, which is gravitational potential energy. Now, why is that? Because we're in a vertical plane. We're in the vertical plane, the y-axis. And so the 50 kilos is experiencing acceleration from gravity. So it's going to be mass times gravity. I'm going to find the weight, then multiply by the height. Now, what do you notice? That's exactly the same as this, which just goes to prove that work and energy, change in energy, are exactly the same. And of course, they have the same formula. So if I do this, it's going to be exactly the same, times 9.81 times 12. And that's going to be 5886. Now, of course, I've just found the work or the change of energy. I still need to divide it by 6. So it's going to be 900 power. Sorry, I need to write it properly. So power is equal to work over time, which is going to be 5886. I'll do it the long, boring way. 5886 divided by 6, which is 981 watts. A machine produces 1,200 watts of power and does 36,000 joules of work. How long does it take? Well, power equals work over time. If you prefer, you can write power equals work time triangle. Okay, so I'm looking for the time. So time equals power over work, which equals 1,200 divided by 30. What did I do? Oops. Yeah, see, that's why you have to check what you're doing. I was like, something's off. Something's off. Power, work, time. Did I make any mistakes like that before? Nope, that's fine. Just checking. Force equals, yep, that's fine. So power, work, time, so that's going to be 1,200, nope, 36,000 divided by power, which is 1,200, and that's going to be 30 seconds. A machine operates 800 watts for 5 seconds. How much energy does it use? So once again, energy is work in this case. Don't be confused by that. So it's going to be P times T equals W, or change in energy, which is what we're looking for. So it's going to be 800 times 5, which is 4,000 joules. Next. Okay, let's do these questions here. If a force of 30 newtons is applied parallel to the motion of an object over a distance of 5 meters, how much work is done? It's parallel. So parallel is a nice word that we're looking for. So that's the force and that's the displacement. If it said perpendicular, there would be 0 work done, but this is parallel, so work is done. It's going to be 30 times 5, which is 150 joules, because work is equal to force times displacement. Okay? Next, what happens to the work done if when the force and the motion are perpendicular to each other? 0. We already discussed that. Which of the following factors affect the gravitational potential energy of an object? Gravitational potential energy is equal to mgh, which is going to be mass times gravity times height. So we've got the mass and the height. Obviously, they affect it. Volume, nope. Shape, nope. Velocity of the object doesn't matter. Next, a 5 kilogram object is moving with a velocity of 2. What is the kinetic energy? It's going to be kinetic energy is equal to half mv squared, okay, which is equal to half times 5 multiplied by 2 squared. So it's going to be 4 times 2.5, or 10. Next, if the mass of an object doubles, what is the velocity? It remains the same. How does the kinetic energy change? It's going to double. Now, the reason for that is because kinetic energy is equal to half mv squared. Now, as you can see, if we keep the velocity the same, let's say, for example, we take mass as 5 and we take velocity as 2, right? Squared. Now, we said the velocity remains the same. What happens to the kinetic energy if the mass doubles? So half times 5 is 2.5 multiplied by 4, and that's going to be 10 joules. So now let's do the same thing. That's scenario 1. Let's see at scenario 2 what's going to happen. So half mv squared, which is equal to half times, this time we get a double the mass. So half times 10 multiplied by 2 squared. And that's going to be 5 multiplied by 4, and as you can see, it's 20 joules, so it doubles. Next, which of the following does not affect the work done on an object? Work equals force times displacement. So force does affect it, the distance affects it. So because that's the displacement or the distance, they both agree. If it's a straight line, they're the same. Direction, of course, the direction affects it, because remember, that's the force and that's the direction. If the force is opposite to the direction, then, the displacement, then it's going to be negative work. And if the force is going in this direction, then it's going to be no work or zero work. So certainly the direction makes a difference. So the only one that has no effect is the mass. And the mass does kind of have an influence if we're trying to work out the weight and if it's in the vertical plane, but otherwise it has no effect. So that's the most correct answer. So which one? It's the mass D. A 4 kilogram object is lifted 10 meters above the ground. What is the gravitational potential energy? Well, you need to know the formula. So GPE equals mgh, which is going to be 4 multiplied by, take gravitational potential energy. This question here says take gravitational potential energy as 10. So since the question says that, I'll just move my face so you can see it. Take G as 10. So since it says that, so I got to take G as 10. So it's going to be times 10 times 10 again. This 10 is for this, and this 10 is for this. Okay, so it's going to be 400. Number 8, a machine produces 2,000 joules of work in 4 seconds. What is the power? Power equals work over time, which is going to be 2,000 divided by 4, or 500 watts. Okay. Number 9, which of the following is true about kinetic energy? Half mv squared. So it depends on mass and velocity. That's what kinetic energy depends on. It depends on mass only. The only part is wrong, obviously. Velocity only? No. Depends on both mass and velocity? Absolutely. It's not affected by either. Of course, that's wrong as well. So it's C. What happens to gravitational potential energy as an object is lowered closer to the ground? So I'm holding an object and I'm lowering it close to the ground. As I'm closing to the ground, obviously it has less height. So an object over here has more height than an object over here. And so this object has more gravitational potential energy than this object, which has a little bit of gravitational potential energy. So what's going to happen to the gravitational potential energy as the height decreases is what the question asks. It's going to decrease. A force of 50 newtons is applied at an angle of 30 degrees to the direction of the motion over a distance of 5 meters. How much work is done? 50 newtons at an angle of 30 degrees, and that is a displacement of 5 meters. So the displacement is fine. It's this. We need to find this force. So there's 2 ways of doing this, as I said. So work is equal to force times displacement multiplied by cosine of theta, or you can find that and then multiply it. So if you're going to use the question as it is, it's going to be 50 times 5 times cosine of 30, and that will give you an answer, which is 250 multiplied cosine of 30, and that is 216 joules. Okay, or 216.5, which is 217, effectively speaking. The other way you can do it is by finding the force, which is SOHCAHTOA. So cosine of theta, it's exactly the same. Cosine of 30 multiplied by 50, and that's going to give you 43.3. And then you can say work equals force times displacement, which is equal to 43.3 multiplied by 5, which is equal to 216.5. Now notice none of the answers is 216.5. The closest one is 200. Next, a 10 kilogram object is moving at 3 meters per second. What is the kinetic energy if its velocity does what? Doubles. If the velocity doubles. If the velocity doubles, what is the kinetic energy if the velocity doubles? So let's just do the scenario 1, scenario 2 thing. Scenario 1, scenario 2. In scenario 1, half mv squared, that's what kinetic energy is, half mv squared. So let's go with half times 10 times 3 squared, and that is 5 times 9, or 45 joules. In the second scenario, we're going to double the velocity. So it's going to be half times 10, because we're going to keep the mass the same, multiplied by 6 squared, which is equal to have 5 times 36, which is equal to 180 joules. So 180 joules, B. A box is dragged 4 meters across the surface with 100 newtons of force, but the friction opposes the motion with, with 60 newtons. Okay? How much net work is done? Okay, so we've got 100 newtons of force. We've got friction, which is 60. And then we've got a displacement, which I'm going to do in a different color because I can. Here we go. Displacement of 4 meters. So that's no issue. That's fine. It's this guy here that we need to sort out. That's no good. So what I need to do is figure out what the net force is going to be. So it's going to be 40 newtons this way, isn't it? So 40 newtons. Now I've got the force and I've got the displacement. So I can just multiply them 40 by 4, which is 160. Okay, because work is equal to force times displacement, which is equal to 40 multiplied by 4, which is 160. Okay, a 5 kilogram object is lifted 2 meters above the ground, held stationary for 10 seconds, then dropped. How much work is done by gravity during the fall? Interesting question. Okay, so what happened was exactly this. So the 5 kilogram object is lifted 2 meters above the ground, held there for 10 seconds, and then dropped. Okay, so we need to work out the gravitational potential energy, because that's the change in gravitational potential energy is equal to work. So either use force times displacement or use mgh. Either or will work. So 5 times 2, 5 times 9.81 times 2, or what's the force going to be? It's going to be the weight force, right? So it's going to be mg multiplied by delta d, which is going to be 5 times 9.81 multiplied by 2. Look at this. That is equal to this. Obviously, it's exactly the same. That's what we've been trying to tell you. So the answer is going to be 50 multiplied by 2 is about 100. Final question. An engine performs 5,000 joules of work in lifting 50 kilogram object to a certain height. What is the power achieved? That should say power. No, what is the height? Oh, okay. What is the height achieved? Okay. So, oops, sorry. So we can do change in energy equals to work, which, so we've got 5,000 joules, and that equals mgh. So we've got 50 multiplied by 9.81 multiplied by height is equal to 5,000 joules. So height is equal to 5,000 divided by 50 times 9.81. So it's going to be 5,000 divided by 500, which is 10. Okay, now, or close to 10. The other way you can do it, that's one way. The other way you can do it is by saying is equal to force times displacement. And in this case, the displacement is the height. So what's the force though? The force is going to be the weight, okay, because we're talking about the y-axis. So the force is going to be the weight. So it's going to be mass times gravity multiplied by delta d, which is the height. So it's going to be 50 multiplied by 9.81 multiplied by delta d is equal to 5,000. So obviously delta d, which in this case is the height, is equivalent to 5,000 divided by 50 times 9.81, which equals 10 meters. Same exact answer. Okay, thank you for that. I hope you find the quiz easy. It should be. You guys have studied hard for it. Best of luck. I'll see you in the next one, inshallah.